So in this video, we're going to solve the equation sine 2x equal to 1/2 on the interval from 0 to 2 pi. What's different here? The argument is 2 theta instead of just sine of theta. Now, sine, let me get back here. So sine of theta would be equal to 1/2 when theta is equal to pi over 6, right? If I draw my unit circle here, that's a square root 3 over 2 comma 1/2. Sine theta is your y value right there, okay? However, this is not sine of theta. It's sine of 2 theta, okay? So what I need to do is I need to make 2 theta be equal to pi over 6. So how do I do that? Well, I just divide both sides by 2 or multiply by 1/2, and I get pi over 12. So theta equals pi over 12. That's in the interval here, all right? And all we have to do to get all those general solutions are add 2 pi k to that. Okay. Ooh, wait a second. Let's think about this. Is 2 pi the length of the period? Well, the period for sine theta is 2 pi for the period. But the period for sine 2 theta, remember to find the period, you do 2 pi divided by k, where I have sine k theta, right? So the period now for 2 theta is 2 pi over 2, which is pi. So actually, I need to get rid of that 2 there, okay? So now this is the period. The period for sine 2 theta is just pi. All right, so we got to be careful there. So if I'm looking at 0 to 2 pi, so pi over 2 is a solution. So k equals 0 gets me pi over 12 for one of my answers. But also k equal to 1. That's pi over 12 plus pi, which gives me 13 pi over 12. So those two are solutions. Now, is that the only way that I can get 1/2? No, I can also get it over here at 5 pi over 6 gets me a 1/2. Okay. So I have 2 theta equals 5 pi over 6 divided by 2 multiplied by 1/2. And so that gets me 5 pi over 12. Okay, so in general, theta is 5 pi over 12 plus, and then the length of the period is pi, so I do pi k. Okay, so 5 pi over 12 is a solution for theta. And I want all of them. So if I plug in 1, I get 5 pi over 12 plus, now pi I could write as 12 pi over 12. And then I get 17 pi over 12. Okay? So those are all the solutions. So it's important. We got to be careful here to not just think, oh, well, 2 pi goes all the way around like this. Well, yeah, it does when the argument is theta. But whenever I do 2 theta, I'm doubling that speed. So what does that mean? That means, so sine works through, so this is sine, so sine of theta, right? That's in 2 pi. However, 2 sine theta is actually going to be twice as fast, meaning I get done with one period of sine in pi units, okay? And then I start another period of sine, and now I've already gone through the cycle 2 times for sine 2 theta. So when I do that horizontal line at 1/2, I don't just have 1 and 2 solutions like I would with sine theta, but I also have 1, 2, 3, 4 solutions in that 0 to 2 pi interval. Okay, so graphing it might help you as well when you're working through that. Okay, let's try another one. So let's solve the equation tangent theta minus pi over 2 equal to 1. And we're going to do it on 0 to 2 pi. Okay? Now, the period of tangent, period for tangent theta is pi. Okay? So the period is pi. So in the interval 0 to pi, the tangent function has a value 1 when the argument's pi over 4. Okay, so the tangent of theta is equal to 1 when theta is pi over 4. That's what I'm saying there. So because the argument is theta minus pi over 2, I'm going to write my equation as theta minus pi over 2 equal to, well, what theta gets me 1? Theta equal to pi over 4. So pi over 4, okay? And since my period is pi, then I add pi k, just like I had my pi k here for all the solutions, right? So to solve for theta, I'm going to add pi over 2, add pi over 2. So when I add, I need common denominator. So I have pi over 4 plus 2 pi over 4 plus pi k. So this gets me 3 pi over 4 plus pi k for theta. Okay, so that's in general. Now, on the interval from 0 to 2 pi, okay, if I do k equal to 0, what's that get me? That gets me 3 pi over 4. That's in the interval. Okay, k equal to 1 gets me 3 pi over 4 plus pi, and I can write that as 4 pi over 4, gets me 7 pi over 4, which is still less than 2 pi. So that one's in my interval as well. Now, if I went one bigger, then that would actually jump me out of the interval. So the only solutions, okay, the solution set is 3 pi over 4 and 7 pi over 4. Okay, those are my solutions for that problem. All right, so now I want to use a calculator to solve the equation tangent theta equals -2. And I want to do it for theta between 0 and 2 pi. So to express any solution in radians rounded to 2 decimals. So round 2 decimals. So always check to make sure your calculator's in radians. So go to mode and hit the radian, enter. Okay, so we're good to go. All right. So to solve tangent theta equal to -2 on a calculator, first thing I want to do is I want to set that equal to try to get theta by itself, right? So how do I get theta by itself? I'm going to arctangent both sides. All right, so when I arctangent both sides, I get theta is equal to the tan inverse of -2. So I'm going to do second tan inverse -2, close parentheses, and I get -1.11. So roughly -1.11 radians. All right. Because of the definition of y equals tangent inverse of x, the angle theta that is obtained, this theta is stuck between -pi/2 and pi/2, okay? For which theta, tangent of theta equals -2. So because we seek a solution between 0 and 2 pi, what's wrong with this? Well, it's a -1.11. All right? So we don't want negative 1.11. So what are we going to do? What are we going to do here? Well, one thing that we can do, all right, if you think about what's going on here, okay, if I think about this graphically, the tangent of theta equals -2. There's like -2/1. All students take calculus, right? Okay, so that means that tangent is positive here and it's positive here. Okay, so it's negative down here and it's negative here. Now, theta equal to -1.1 rotates about like this. Theta equal -1.11. Okay. Now, my solution is only for 0 to 2 pi. Okay, what do I know about the period? Okay, what do I know about the period for the tangent? All right, the period for the tangent is pi. Okay, the period is equal to pi. So if theta equals -1.11, then to get the next one, I just do pi k, right? So to get an answer, all the answers between 0 and 2 pi, I'm going to add. So if I did 0, I get the original one. But if I do k equal to 1, I get -1.11 plus pi. That's a solution. So what does that look like? That takes this right here, adding pi, rotates me all the way around to right here. So that's plus pi to my angle. Okay, so theta here, that's one of them. Okay, so that's good. What about k equal to 2? K equal to 2, theta is going to be -1.11 plus 2 pi. Is that going to be less than 2 pi? Yeah, because I'm subtracting that negative number. So these are my two answers right here. Okay? If I add another pi to that, that's going to actually make it greater than 2 pi. And so those are the only two answers. So basically this is an answer. And then if I rotate it all the way around 2 pi, then I get back here. So those are both answers there. Okay, tangent is negative in quadrant 2 and quadrant 4. Okay? So my solutions, I need to do -1.11 and then plus pi. So -1.11 plus pi gets me 2.03. Okay, so theta equal to 2.03, but also I need to do negative 1.11 plus 2 pi, which is 5.17. 5.17 is my other solution, okay? And so is this between 0 and 2 pi? Remember 2 pi is simply 6.28 roughly. Those values definitely, those are between 0 and 2 pi there, okay?